Welcome you all to the Gnana Taranga NEET and CET coaching for engineering and medical entrance examinations 2018-19. This program is organized by Pre-University Education Department, Government of Karnataka, and my name is Dr. A.S. Govind. Today I will be taking the physics topic, electrostatic potential and capacitors. First we will cover the synopsis and then we will go to the questions. So now coming to the synopsis, the definition of electric potential is work done per charge and therefore W by Q, and hence the unit of potential will be joule per coulomb. Potential is related to the field. So electric field is defined as a negative potential gradient and minus dV by dr. So this implies, because electric field is a vector while potential is a scalar, so this has to be understood properly. So if potential is varying in a particular direction, for example, if we have a charge here, some positive charge, the potential V1 here will be more, potential V2 here will be less. So obviously potential is decreasing as you go away from the charge, and electric field is in the direction of decreasing potential. That is the meaning of the negative sign here. So electric field as a vector is in the direction of decreasing potential. So this has to be remembered to solve many questions. If you move in the direction of electric field, the potential decreases. That is an important point to remember. Then some standard equations have to be remembered. So when you consider a charged conducting sphere, so the conducting sphere obviously means charges are uniformly distributed on the surface because it is a sphere, and charges are present only on the surface because it is a conducting sphere. So just for comparison, I have also mentioned the field equations. We are using the equations of the potential. So when you are outside the charge sphere, the important thing here is the potential varies as 1 by r. Potential varies as 1 by r. Charge by r, k is this 1 over 4 pi epsilon naught. This has to be changed if there is a medium outside it, and this is the equation for vacuum. So it is proportional to 1 by distance and also proportional to the total charge present. Then when you are at the surface, this r has to be replaced by capital R, which is the radius of the sphere. And when you are inside, that is important to remember, it is same as this answer. So when you are on the surface and you go anywhere inside, need not be in the direction of radius, anywhere inside the conducting sphere, potential is same as what is there at the surface, and therefore it is a constant. Since potential is constant, change in potential with respect to distance will be 0, and therefore dV by dr is 0. So that means the electric field inside will be 0. Then at the center also the potential is same as what is there at the surface. So now going further, if you consider a linear charge, again the electric field equations are mentioned, which you have already studied, and if you want the connection to the potential, you have to use the equation E equals minus dV by dr. That is the equation to be used. Then going further, uniformly charged circular ring at a point on the axis. So this is important. We are not calculating potential or field somewhere here. So here the equation is quite complicated. What you have in the syllabus is some point somewhere along the axis at a distance x. So only that is what is considered. And notice that the field varies as r square power x square to the power 3 by 2, whereas the potential varies as 1 by r square power x square to the power half, that is root of r square plus x square, and root of r square plus x square is actually this distance. So that is sometimes easy to remember. This is r and this is x, and therefore this is the distance which is coming in the denominator of the equation. And if x is very much greater than r, this part r square plus x square can be neglected, and therefore it becomes r square to the power half, and therefore it when x is very much greater than r, this r can be neglected. I told x, so make that correction. This r can be neglected because x is very large. The radius, that means you have a coil which is small compared to the point where you are measuring the field. So I have gone very far away from the coil, and therefore this x square r square to the power half plus x square to the power half becomes, if you neglect this, you will get x square to the power half, and this simply becomes x. So notice that this is same as the equation for a point charge. That means the entire ring of charge appears just like a small point charge because they have gone very far away from that. That is the conceptual way of understanding that. If you are closer, then the dimensional effects will come, and therefore you are getting r square plus x square to the power half. So going further, when you have a dipole, the electric dipole moment is q into 2L, and what is important to remember here is 2L is the total distance between a plus charge and a minus charge. This total distance is taken as 2L. So in any question, if it is just given as A and both the charges are equal and opposite, then the dipole moment will be just QA, and by mistake we should not take another 2 in the calculation. The actual distance is taken as 2L. That is an important thing to remember. And we measure the other distances from the midpoint. If you go somewhere here, if you say R, then it is the distance measured from the midpoint of the two charges. And many a times we consider a short dipole. When you say a short dipole, it means this distance between the charges, 2L, is very small compared to the distance of the point where we are considering the field or potential. So the electric field varies as 1 by r cube root of 3 cos square theta plus 1, where this is the theta. So it depends on r and theta in this fashion, and electric potential varies as p cos theta by r square. So what is important to remember here is potential is proportional to 1 by r if it is a single charge. Potential is proportional to 1 by r square if it is a dipole. So this is an important thing to remember. Inverse square law for field is valid only for a point charge. The field varies as 1 by r cube here when you have a dipole. And if you put the dipole in an external electric field, there is a turning effect which is called torque, which is P cross E, which becomes Pe sin theta in the magnitude. Actual direction is given by P cross E vector. And if you rotate a dipole in an external electric field, because you are rotating against a torque which is already present there, work is done against the torque, and small work done for a small rotation is tau into d theta. So P sin theta d theta, and for rotation between some one theta to another theta, the total work done is the integral of this. So you are getting it as cos theta difference, Pe into cos theta initial minus cos theta final. That is the total work done in rotating the dipole from theta I to theta f. This theta is measured with respect to the electric field. So if you have an electric field like this, and if you have a dipole moment is a vector. So notice that dipole moment is a vector here, and the electric field of the dipole goes like that from positive charge to negative charge, and within that it goes this way from plus to minus, and electric dipole moment is a vector which is taken from minus to plus. This is the direction of the P if you take it as a vector. So this is the vector P, and this is the theta which is present in all these equations. Going further, for capacitance I have put all the equations together because anyway you have to remember them. Deriving any of them is not required for your CET or NEET exams. So you should be familiar with all the symbols that are present here. So what is important here is capacitance is defined as the ratio of Q and V, and this has to be understood conceptually, and that helps a lot in calculating some series, parallel, combination, energy loss and other things. So, C is Q by V is a ratio which is constant. Just because Q is present in the equation, you should not think that C depends on Q, C depends as 1 by V and all is a wrong concept. If Q increases, V also increases in the same proportion, so that Q by V ratio is a constant, and that constant is the capacitance of the capacitor, unit is the farad. And now this can be understood by a water analogy, just like if you have a tank, it has some capacity, let us say it has some capacity 200 liters, and I have a bigger tank, let us say which has capacity 500 liters. Now obviously if the level of water is same, the quantity of water is equivalent to quantity of charge, and level of water is equivalent to potential in the comparison. So if the level is same, obviously this second tank has more water. So in the same way, if you call this as C1 and C2 as the water storing capacity, but here we are talking of charge storing ability. So if C is more, whenever V is same, Q should be more. That is one example. Next thing, which is obviously what you can think by common sense, if I put same amount of water to both the tanks, that means I take some 100 liter and put it to both of them, this will become half filled, and this level will be very, very low because it is a bigger tank. So if Q is same, bigger tank will have a lesser level. So whenever Q is same, the level which is equivalent to potential is inversely proportional to C. Actually these things can be obtained from this equation. So you have C equals Q by V, and therefore Q equals CV, which means proportional to V, which is what I told. If C is constant, then if you take it the other way, V is equal to Q by C, and if Q is constant, then you are getting V proportional to 1 by C. That is the meaning of this. So these things are very much useful when you are solving capacitance connected to one to the other and all. You can get the answer by some shortcut methods without actually doing lot of calculations. And we consider various different types of capacitors. This is the equation for parallel plate capacitor. So you have two parallel plates of area A separated by a distance d, and in between if you have a dielectric of constant K, otherwise if it is air or vacuum, this K is taken as 1. So C is epsilon naught Ka by d, and without dielectric you will have epsilon naught A by d, and therefore when you take the ratio of C with dielectric and C with vacuum or air, you will get the dielectric constant. Even though the equation looks very simple, this equation is actually used even at very high research levels to find the dielectric constant of materials. And when you consider the electric field is less inside the dielectric medium. So E is the electric field. So if you take it the other way, cross multiply, you will get E equals E naught by K. So electric field reduces in the inverse proportion of K. If K is 1, that means air or vacuum, both are same. If K is more, electric field inside the dielectric will be less. And this is the difference between the what is present in air or vacuum to what is present in the dielectric. So now this is a important thing to remember. If you are having a capacitor with dielectric partly filled, so I can put a dielectric only for small region like that. So the total distance between the capacitor is d, and the dielectric has only a thickness T, which is less than d, and this has a dielectric constant K. Then you have to use this equation, d minus T. This way it is easy to remember, instead of taking T constant, common factor. So d minus T is the space without the dielectric, that is this plus this. D minus T is the remaining space. T is the size of the dielectric. So remaining space minus T by K is what comes in the denominator. And obviously if you put the dielectric full, then this d minus t will be 0, t becomes equal to d, and therefore you will get back this equation. So that is the way you can remember that. And now this is important because if you put a metal here for one portion of the capacitor, if you put a metal, then the dielectric constant of a metal is infinite, and therefore this part becomes 0. So it is as though this much of capacitor is absent because I have put a metal here. This can be imagined as one small capacitor and another capacitor, and therefore this part can be squeezed to 0. So it becomes a capacitor of only d minus t distance. So that is the way you can understand the effect of a dielectric. This is the capacitance of a spherical capacitor of radius r kept in vacuum or air, and this is for a spherical capacitor with the radius b and a. Outer radius is b and inner radius is taken as a. That is why you are getting b minus a here. So notice that if you get confused which is a and b, remember this should not be negative. So obviously b should be more than a. That is the way you can remember. So similarly here, this is for a cylindrical capacitor with two concentric cylinders. Outer one has a radius b, inner one has a radius a, and the capacitor just goes like a cylindrical one, concentric cylinders with the coaxial cylinders with the common axis. So notice that both of these are valid only if in case of sphere it should be concentric, and in case of cylinder it should be coaxial. If you displace it, the equation becomes very complicated. So then going further to series and parallel. In case of series, remember it is similar to resistances in parallel, the nature of the equation. 1 by Cs goes as sum of reciprocals, and therefore Cs will be less. When you put the capacitor in series, the value decreases, and if you put n equal capacitor in series, Cs will be C by n. So that is an important thing to remember. And when you have only two of them, it is easy, you can cross multiply, simplify and remember it as a final equation. Cs will be C1 plus C2 by C1 C2 inverted, and therefore you are getting it as a product by sum, and that is an easy way to remember, and you can most of the times do it orally if the values are simple. For example, if I have 6 and 4, it will be 6 into 4, 24 by 10, so that you can easily say it is 2.4 without doing all these calculations. When you come to parallel, it is just the sum, and therefore Cp, it is more than the value, each of the values that are present. So these concepts are important to do some shortcuts. Cs is less than the least of the capacitor. Whatever is connected in series to any other capacitor, the value is less than both of them. Similarly, Cp is more than each of the value that is present in the combination. If you put n of them in parallel, obviously it becomes n times C, and you can notice that if you compare these two, this is n square of Cs. So for n capacitors connected in parallel, the effective value is n square of same n capacitor connected in series. And other things that are important to remember here is, when you put capacitor in series, Q is same, and as I told, if Q is same, C and V are inverse proportional, so V proportional to 1 by C, and this is an easy way to do some shortcuts. When they are in parallel, V is same. So again, coming back to this equation, if V is same, Q and C are proportional. So charge present in a capacitor is proportional to the value of the capacitor. So when they are in series, a bigger capacitor has a smaller voltage. When they are in parallel, bigger capacitor has more charge. So that way you can remember and choose the answer quickly. Now going further, energy stored in the capacitor, easy way to remember is half CV square. Actually these two you can obtain by just using the equation C equals Q by V, even if you don't remember them. So it becomes Q square by C and also half QV, different forms of writing it. And this is actually energy density, energy per unit volume. For example, if I have a parallel plate capacitor with some area A here, the volume of the capacitor inside that is therefore A into D, and you have to divide this energy by A and D, then you are getting this half of epsilon E square, and this is called energy density. This also shows that energy is stored in the electric field, not in the plate or anywhere. It is stored in the form of electric field. Now, when you put the capacitors, connect them in parallel, there is a sharing of charges, and the common potential that you get is the total charge by total capacitance. Total charge is Q1 plus Q2, C1 V1 plus C2 V2. Total capacitance is C1 plus C2. And again, you can use the water analogy here. If you have two tanks, one smaller and one bigger, having different levels of water like that, connecting them in parallel is equivalent to connecting them here. So obviously this decreases, this increases, you will get some common level here. So it is by common sense you can see that the common level that you get should be between these two. So that means if you have V1 as some 10 and V2 as some 20, this common potential cannot be less than 10 or cannot be more than 20. It has to be between this 10 increases, 20 decreases, and finally you will get some equilibrium value, which is the common potential. So that way, only by that concept may be sometimes enough to choose the answer. And this is the change in energy, loss of energy when charges are shared. And usually you need not remember the equation, you can calculate individual energies by this equation and then take a difference. That will be much easier. And another important thing that you have to understand is, if you have a capacitor which is already charged, and after that some variations can be done. For example, D can be varied, dielectric is introduced or removed, something like that. Then what happens? So such things can be analyzed under two cases, A and B. First case, the charging cell is still connected. So whenever you have the connected cell, the potential of the capacitor cannot change, because if the potential decreases, the cell will again charge it to the same potential, like that. So this is the concept to be used. So potential is same, and the C dash you have to find based on what is the condition given. So let us say they have given D increased. So if D is increased, using the parallel plate equation, C is epsilon naught A by D. If D is increased, C dash, because it is inversely proportional to D, is decreases. That means capacitance of the new capacitor is less. And because C decreases and V is same, if you again use C equals Q by V, V has not changed, C has decreased, and therefore charge should have decreased. What has happened to charge means it will have gone back to the battery, because they have still connected the cell. So after this you can calculate energy and electric field and all. Similarly, any other thing, dielectric introduced and all. And now if the charging cell is removed, the charge cannot go anywhere. So now you should use the condition Q same. Now if D is increased, the same condition given, D increased, C dash, because D has increased, C dash has decreased. That part is same. But now Q should be same, and in this equation Q is same, and C and V are inverse proportional. So if C decreased, V should have increased. So potential should have increased. And based on that, you can calculate other things. So anyway, we will use this when we come to the questions. And for all of them, use the common procedure. When the cell is still connected, V is same. When the cell is removed, Q is same. That is the first point. And after that, depending on the condition given, use the equation to find what is the new value of C. And after that, use C equals Q by V in combination with either this or this. And after that, you are getting Q or V, and then you will get E, U and other things. So now we will go to the questions on electric potential. First one, equipotential surfaces associated with an electric field which is increase in magnitude along x direction. So if you consider the x direction here, according to the right-handed coordinate system, x and y, if they are like this, z should be here, that is the way. So, if electric field is only increasing this way, not changing in any other direction, that is what is given, and therefore equipotential surface should be perpendicular to this. So, equipotential surface should be in this plane, so that electric field comes like this. So, it has to be in the YZ plane, parallel planes. So, that means you can have one more equipotential surface like that, parallel planes, all of them are in the YZ direction, and therefore, the correct option for the question 1 is B. Going to the next question, in a region potentially represented by 6x minus 8xy minus 8y plus 6yz, V is in volt, xyz are in meter. So, this is given so that it is already in SI units. The electric force experienced by a charge of 2 coulomb at this point. So, xyz values are given, charge is given. So, the F equals QE to be used with the Q as 2 coulomb. So, and therefore, first thing we have to find is the electric field present here. So, for that we are using E equals minus dV by dx for the x direction, similarly for y and z direction, and then you can represent it by IJK notation. So, therefore, because it depends on all of them, you should consider partial differentiation here. So, the variation in x direction gives x component like that. So, if you consider dV by dx only, you have x here and here, and therefore, you are left with 6 minus 8y. This is the x component with I unit vector, and when you consider the y differentiation, it is present at 3 places here. So, when you differentiate partially, other things remain constant. So, you are left with minus 8x minus 8 plus 6z. This is in the y direction, and for z you have only one of them. So, therefore, you are having plus 6y in the z direction unit vector. This is potential gradient, and minus of this is the electric field. So, now to find the force, because they have not asked the direction, it is enough to find the magnitude of this. So, simplifying this with x1, y1, z1, that is given here, the point x, y, z 1 each. So, putting all of them 1, 6 minus 8 minus 2i, and this is minus 8 is 16, minus 16 plus 6 is 10, minus 10, and then y is 1, so plus 6 k. So, magnitude of this vector is sum of the squares of this under square root. So, magnitude of this vector is 2 square plus 10 square plus 6 square under square root. So, this is 4 plus 100 plus 36 under square root, and therefore, it is square root of 140, and 140 you can take out 4, and root of that becomes 2. So, I will write it as 2 root 35. This is E. This has to be multiplied by Q to get the force, and Q is 2. So, this into 2 therefore becomes 4, and therefore, this is your answer. For the second question, the answer is D, 4 root 35 Newton. Because these are in SI units, the answer is in Newton. Then going to the third one, potential energy of a particle is given as A by r square minus B by r, where A and B are positive constants and r is the distance of the particle from the center of the field. That means source of that. For stable equilibrium, the distance of the particle is. So, notice that stable equilibrium corresponds to net force becoming 0, and net force becomes 0 if the field becomes 0, and therefore, the differentiation of this should become 0. So, the condition to be adopted for stable equilibrium is this du by dr should be 0, and when you differentiate that, 1 by r square becomes minus 2 by r cube A, and 1 by r becomes minus 1 by r square B. This has to be 0, and therefore, taking it to the other side and cancelling r square, you are getting 2a equals RB, which gives you R equals 2A by B. So, therefore, your final answer to be taken is 2A by B. That means potential is varying in this fashion, and at this point R equals 2A by B, the change of potential is 0. That means it will be becoming like that, and this is the point corresponding to stable equilibrium according to this equation. 2A by B, option C is your final answer. Then going further, electric charges plus Q, that is here, minus Q here, are placed as shown, and the side of the square is 2L, and A is the midpoint, and therefore you are having L each here. Electric potential at the point A is to be found out. So, you should find the potential here. So, for that we need these distances. So, first you can keep it ready just using Pythagoras theorem. L square plus 4L square, 5L square under square root becomes L root 5, that is this distance. So, you have to find the potential is a scalar, so you have to add the potential due to all the 4 charges. So, if you consider the potential due to these two, because they are equal, it is 1 by 4 pi epsilon naught charge by distance Q by L, and this is also same, so that becomes 2. And for these two, it is 1 by 4 pi epsilon naught minus Q by distance is L root 5, again into 2, because there are 2 such charges, and it is these two to be added. So, obviously 1 by 4 pi epsilon naught and 2Q becomes common, L in the denominator also becomes common. You are left with 1 here and 1 by root 5 here with this multiplier. So, obviously this corresponds to this option, and you have to choose the option B. Now, for many questions you will also have a shortcut method. So, you can see that once you calculate that this is L root 5 and potential varies as 1 by distance, root 5 should come in the denominator, and because distances are unequal it won't cancel out. So, obviously these two are wrong, which you can immediately decide, and because one is plus other is minus, your answer should be something minus something like that. It cannot have a plus, so this is also wrong. So, this method of doing is called elimination method. You can eliminate the wrong answers, and without doing much of calculation, you have done only this calculation. Without doing much calculation, you can decide that this is the answer, B is the answer. So, wherever it is possible to do elimination method, I will explain how to do that. But as a practice to become faster, that means to get the correct answer quickly, you should practice doing elimination methods, which itself has a lot of varieties. One of the varieties is just seeing the trends like this and guessing the answer without doing the full calculation. Yes, going further, based on a similar concept, electric potential at XYZ is given. Electric field at that point has to be found out by the same way which we did earlier. First differentiate with respect to x partially multiplied by I. So, and also you should have a minus. So, when you differentiate this partially with respect to x, these two terms will appear. So, x square becomes 2x and y is a constant, minus x becomes 1 and you will have a z cube, and because you have a minus of this, that comes outside, which you can take later. So, this comes with x component, and if you differentiate with y, only this one will be present. So, minus x square comes with j, and differentiating with respect to z, only this term will be present. So, minus x is a constant, z cube becomes 3z square, and that comes with a k, and all this together to be multiplied with a minus sign. So, 2xy plus z cube plus x square into z and 3z square x into k. So, coincides with the first answer, and therefore, correct option for the question number 5 is A. Now, going further, charges plus q and minus q are placed at the points A and B. So, you can mark that plus q and minus q are placed here respectively, which are at a distance 2L apart, and C is the midpoint. So, this is L, this is also L, because C is the midpoint between A and B. Work done in moving a charge plus q along the semicircle CRD. So, notice that work done is q dV, and dV here is the potential difference between initial and final points, and it does not depend on the path. That is an important thing to remember. So, therefore, in this case work done is charge into potential difference. Difference is always taken as final minus initial. So, it is Vd minus Vc, and here you can see that because C is the midpoint and you have equal and opposite charges, distances are equal, plus q by L and minus q by L into for 1 over 4 pi epsilon naught will cancel out. So, potential at C will be 0, and therefore, you are left with only this one, charge into potential at D, and this is also L because it is a semicircle. L will be the radius of that. So, therefore, potential at D is what you have to find. Potential at D due to charge at A is 1 by 4 pi epsilon naught, charge at A is q, by the distance between A to D is 3L, and you have one more charge here which is causing potential, 1 over 4 pi epsilon naught, charge at B minus q, which is at a distance, this distance is L. So, if you take this as a common factor, 1 over 4 pi epsilon naught q by L as common factor, you will be left with 1 by 3 minus 1. So, 1 by 3 minus 1 is 1 minus 3, that is minus 2 by 3. So, this part becomes minus 2 by 3, and this will cancel with a 2 here. So, 3 into 2 you are left with a 6 here, and this has to be multiplied with the charge q to get the work done, and therefore, your final answer is minus 1 by 6 pi epsilon naught L. So, this 2 and 3 are giving you 6, you have a minus here. So, minus 1 by 6 pi epsilon naught L, this q and this q multiplied is small q into capital Q. So, the correct option is D. Going further, this is a similar one. As per this diagram, a point charge plus q is placed at the origin. So, I have a plus q here. O, work done in taking another point charge minus q from A to B. So, you have a minus q here, you are moving it from A to B. What is the work done? And where is A? A is at 0 comma A. So, x coordinate is 0, y coordinate A means this OA distance is A. B is at A comma 0. So, x coordinate is A, y coordinate 0 means it is on the x axis. So, notice that these two distances are equal, and if you use the same equation dw equals q dv, same equation, this dv is the potential difference, final minus initial, this is the way, and because this charge is same for both of them, distance is also same for both of them, these two potentials are equal, and therefore, you will get an answer 0. So, this has to be done carefully. Unnecessarily, you should not find the distance and other things and waste time. So, the correct option is 0 here, because A and B are having the same potential, and it does not depend on the path, whether it comes this way or it goes in a semicircular path, quarter of a circle like that, or you go in a square path like this. Whatever happens, we are interested only in the initial and final points and potential difference between them. That is an important concept. So, option 7, correct option is A. Then going further, identical charges minus q are placed at each corner of a cube of side B, then electric potential energy of charge q which is placed at the center. So, they are not asking potential energy of the entire system, you have to find the potential energy of only this charge because of all other charges at the corners. So, obviously, remember, because it is a cube, you will have 8 corners, and because you are calculating at the center, all of them will be at the same distance, and potential energy is a scalar. So, it is enough to do the calculation for one of them and then multiply by 8. So, if you have a cube, this cube has a side B which is given. So, all these are B, and the body diagonal of the cube, that is this corner to opposite corner, which passes through the center, body diagonal of the cube is this square plus this square plus this square, and all are B, and therefore, this body diagonal is 3B square and square of that. So, this is square root of that. So, body diagonal is therefore is equivalent to B root 3, and we need half of that distance. So, distance of the corner charge minus Q to the plus Q, this half distance, it is same for all the corners, that is why we are calculating one of them. So, this distance is half of this. So, it is B into root 3 by 2, that is the distance, and therefore, potential energy of these two charges alone is minus Q into Q, which is Q square by 4 pi epsilon naught, and distance, this is the distance D, we want 1 by D. So, this should be inverted, 2 by B root 3. This is for one of them, and the total potential energy of all of these minus charges in all the 8 corners is to be multiplied by 8. So, you can see that 4 2s are 8. So, you should get 2 into 2 4 with a minus in the numerator, Q square pi epsilon B root 3. So, that coincides with this one, minus 4Q square root 3 pi epsilon naught B. So, this correct option is D. So, again coming back to this, I have told you, you should always try out an elimination method, and if it works out, don't waste time by doing lot of calculation. That you should always remember, because many of the questions will be very similar to your problems in the board exam, which you will take nearly 7-8 minutes to solve. And if you do it in the same way, here also for each question you may take 8 to 10 minutes, which is very difficult if it happens like that to cover up all the questions. So, therefore, what is the quicker method here? Once you notice that this has a root 3, you have not done all these calculations, you have just done this, the distance has a root 3, and you will get the distance in the denominator. So, answer should be something like this. It cannot be anything other than this. It should have a root 3 whatever is present here, and this is the only one which is having that form, and you are not having any other numbers here which will cancel with root 3, and therefore, your final answer should have a root 3 in the denominator. So, if you just get that idea, immediately after doing this calculation, without doing all these calculations, you will directly say this should be the answer, because others cannot be the answer. So, you have eliminated all these things. So, all these are eliminated because they are not having a 1 by root 3. So, this kind of a shortcut you should always practice to be faster. Otherwise, it is very difficult to get high marks in either CET or NEET exam. Going further to the next one, helium ion, hydrogen ion. So, hydrogen ion is just a proton. So, it has a plus EF charge. Helium ion, if one electron is removed, it will have a plus E. So, that is given here. So, this will also have a plus EFA charge, are accelerated from rest through the potential difference V to velocities V1 and V2 respectively, then that ratio is asked. So, if they are accelerated through the same potential difference, because they have the same charge, they will have the same kinetic energy. So, the first point to notice here is kinetic energy for both of them is same. Now, you just substitute half mv square for 1. So, let us take helium as 1, hydrogen as 2, that is the way they have given here 1 and 2. So, half mv square for the helium is should be equal to half mv square for the hydrogen, helium ion and hydrogen ion. Now, this half is cancelled, V1 by V2 should be therefore cross multiply root of M2 by M1. So, M1 means mass of helium ion, and this is hydrogen ion, which is just a proton, and helium ion, neglecting the electron mass there, is 4 times hydrogen. So, therefore, it becomes square root of 1 by 4, that is m1 is 4 times m2, and therefore you are getting square root of 1 by 4, which is a half. So therefore your final answer for the ninth one, B, is the correct option. Continuing further, we are now discussing the question number 10. Figure shows 3 points A, B, C in a region of uniform electric field E. The line AB is perpendicular to BC, that means this is 90 degree. AB is perpendicular to BC, BC is parallel to the field lines. So that is visible here. Then which of the following holds good, where VA, VB, VC represent electric potential at the points A, B and C respectively. So now if you consider E equals minus dV by dx, and if you take this as the x direction, I have already explained, if you go in the direction of electric field, the potential decreases, that is the meaning of this minus, and these are electric field lines, and therefore if you go in this direction, potential should decrease, and therefore VC should be less than VB, because potential should decrease. And then if you go in the perpendicular direction, then potential should not change, because electric field everywhere here is same, and therefore potential should not change in this direction, and a line perpendicular to the electric field becomes an equipotential line, and therefore VA and VB should be equal. This happens only if you go perpendicular, and they have given that the AB is perpendicular to the field lines, because BC is parallel to the field lines. So therefore you have VA equals VB, and both of them should be more than VC, and that is with this option B, VA equals VB and both of them are more than VC. For the question 10, the correct option is B. So again notice that these are all conceptual questions based on this simple equation, electric field is negative potential gradient. Going to the next question, two thin concentric, so notice that concentric, hollow, conducting, so even every word you have to read carefully, conducting spheres of radii R1 and R2 carry charges Q1 and Q2 respectively, that is shown here, Q1 and Q2 respectively. R1 is less than R2, that is also shown here. Then the potential at a point at a distance R such that it is between R1 and R2. So it is somewhere here, it is in between the two spheres. The point of consideration is in between the two spheres. Now what is the concept here? When you have a charged conducting sphere, the potential anywhere inside is same. So if you have a charged conducting sphere, potential anywhere inside is same as the potential at the surface. So therefore for the external sphere which has a charge Q2, potential anywhere inside is same as the potential at the surface. So effect of this sphere is 1 over 4 pi epsilon naught charge by its radius, that is the potential of outer sphere Q2 inside at the point of consideration. Then if you have a charged conducting sphere, if you go out of that sphere, then you have to consider the distance from the center up to this point and use the standard equation which varies as 1 by r. So for the other sphere with Q1 charge, you are outside the sphere, center distance is r, and therefore this potential is 1 over 4 pi epsilon naught, its charge by distance from the center, Q by r, and potential being a scalar, you have to add these two. So 1 over 4 pi epsilon is common, Q1 should have 1 by r, Q2 should have capital R2 in the final answer. So therefore this is the correct option B for the question number 11. Going further, in the electric field of a point charge Q, so notice that it is given as a point charge. A certain charge is carried from A to B C, D, E. That means you can go A to B, A to C, A to D, A to E. So there are 4 different paths which are possible. Then the work done. So notice that this is a circular path and the given point charge is at the center. So if you have any point charge, then at some distance you have a potential, and because potential is a scalar, it does not depend on the direction. So wherever you go at that distance, potential will be same. So if you consider a circular path like this, potential everywhere here will be same. So therefore, VA, VB, VC, VD and VE all are equal, because all of them are points at the same distance from this point charge Q. So potential at all these points are equal is the first point to consider. Then the next thing, whenever any charge is moved, whatever is the path, the work done is charge into potential difference. So you take any path, A to B, potential is same. You take A to C, potential is same. So like that, for all the 4 paths given, this potential difference is 0, and therefore work done is 0 for all of them. So you have to choose this option. The work done is 0 along any of the paths AB, AC, AD and AE. All of them are 0 because they are all points at the same potential. Going further, question number 13. This is based on the concept electric field is minus dV by dr. Same equation which we have already used. Variation of potential in volt, distance in meter from a fixed point is as shown in the figure. So there is something here which cannot be a point charge obviously, some source. If you go away, potential first increases up to 2 meter, 2 to 4 it is a constant, 4 to 6 it will come back to 0. So for some kind of a source, potential varies like this. Electric field at r equals 5 meter. So you have to find the electric field here at r equals 5 meter. So at this point, electric field is minus change in potential by change in distance, that is potential gradient. Now you see this dV by dr, if you have a graph of V and R, this dV by dr represents the slope. So it should be minus slope. So you have to find the slope at this point. So for that you can consider this itself as the right angle triangle. This is dV and this is dr. dV is this height which is 5 and dr is 4 to 6 which is 2. So dV by dr is therefore 5 by 2 in the unit volt per meter is equal to 2.5, and electric field is minus of that. So therefore your answer should be minus 2.5, which is this option with the units volt per meter. That is why they have given the units of each of that. So option B is the correct option for question number 13. Going further to the next one. 2 charges Q1 and Q2 are placed 30 centimeter apart as shown in the figure. So Q1 and Q2 are placed 30 centimeter apart, that is the first part. A third charge Q3 is moved along the arc of the circle, radius 40 centimeter. So this is a circular part and therefore this distance is 40, similar to this distance, because this is arc of a circle from C to D. The change in potential energy of the system. So you should consider the change in potential energy of the system. That means you should consider the potential energy before the movement when you are having ABC charges. You should consider the potential energy when the system is A, B, D, and then take the difference. That gives you change in potential energy. And to do that, we need not consider potential energy of Q1, Q2 itself, because anyway there is no movement in that, and when you subtract it goes off. So consider only the potential energy of Q3 with respect to the others, because that is the one which is moving. So, potential energy at C, when you consider potential energy at C, so what is the equation for potential energy? Potential energy of two charges is 1 over 4 pi epsilon naught product of the charges by distance. So, remember, if you do r square, you will get force. If you do r in the denominator, you will get potential energy. If you put r square here, it is similar to the Coulomb's law. So, potential energy varies as 1 by r. So, at C, you have to consider this pair and also this pair, these two. So, this is, you can see by Pythagoras theorem, if this is 30, 40, this should be 50. It is just like 3, 4, 5, which is a Pythagorean triplet. So, therefore, you know both the distances, but because they are in centimeter, 40 centimeter should be taken as 0.4 meter, 50 is 0.5 meter, 30 is 0.3 meter. Okay. So, now at the point C, when the charge is at C, initial condition, this potential plus this potential. So, you are having 1 over 4 pi epsilon naught, I will take it as common, product of charges by distance q1 q3 by 40, which is 0.4, plus then product of these two, 1 over 4 pi epsilon naught is already here, product of the other two, q2 q3 by 0.5. This is the potential here. Now, you consider the potential when the charge comes to D. So, q3 should be taken here at D, and this is not present because that has come here. So, again, when you are at D, 1 over 4 pi epsilon naught, the product of charges, this and this, q1 q3 by the total distance, which is 0.4, because this is arc of a circle, this distance is same as that distance, plus for these two charges you have to calculate q2 q3, and the distance between them is 40 minus 30. So, it is only 10 centimeter, which is 0.1 meter. And you want the change in potential energy, means you have to take a difference. Difference is always taken as final minus initial. So, this minus that, and when you subtract, this part gets cancelled because it is equal, and therefore, you are left with 1 over 4 pi epsilon naught q2 q3 product, this minus this. So, therefore, 1 by 0.1 minus 1 by 0.5. 1 by 0.1 is 10, 1 by 0.5 is 2, and therefore, this part becomes 8. So, they have already given q3 by 4 pi epsilon naught. So, what remains with k is this with this. So, you should have 8 q2. So, 8 q2 should be the multiplier here to get the answer. So, k is 8 q2, that should be the answer. So, option A is the correct option for question number 14. Going further, 15, 3 charges minus 2q plus 2q minus q are placed as an equilateral triangle. What is the dipole moment of the combination? So, notice that you can split this 2q as q and q. So, take one with this and one with that. So, dipole moment of the two. So, you have one dipole moment here, another dipole moment here, and the two are vectors. You have to add them like vectors, and you see that when you take them as two vectors, you will get this angle. Equilateral triangle means it is 60 degree, and both the dipole moments are equal. So, dipole moment is distance and product of the charge. So, it is qa. So, I have already told you should not take a 2 here, because this itself is taken as 2L in the definition. So, it is qa is the dipole moment, and you have two such things at an angle 60 degree, and you have to find the resultant. So, remember your first PUC equation, R is root of p square plus q square plus 2 pq cos theta to find the resultant of any two vectors from the parallelogram law. So, here both are p. So, both are p. So, it becomes root of p square plus p square, which is 2p square, plus 2p square, because pq is p square, cos 60 is half. So, this cancels here. So, you are left with 3p square under square root. So, it becomes p root 3. So, therefore, p is this into root 3 should be your final answer, and therefore, you are taking the option C as the correct answer for the question number 15. Then, going further, electric flux through a hemispherical surface of radius r placed in the uniform electric field parallel to the axis. So, if you have a hemispherical surface, this is the circular plane, axis of that is here, and they have given hemispherical surface of radius r placed in a uniform electric field. The direction of the field is parallel to the axis. So, electric field lines are like that. So, this is the uniform, means they are all parallel lines of equal distance. So, flux is calculated for this area. This shape does not come into picture, because whatever goes in this area is going through this sphere. So, you have to consider this area, because when you define flux by areas field, you are considering the normal component of that. So, for this area it is perpendicular, and therefore, field is flux by area, and therefore, flux is field into area, and area of this is pi r square, and the field here is E. So, therefore, pi r square into E. That should be the answer, question number 16, option B. Then going further, so now we move on to some questions on the capacitance topic. The first one, a capacitor of capacity C1 is charged up to V volt and then connected to an uncharged capacitor of capacity C2. Then what is the final potential difference across each? Because they are parallel, it is same. So, you already remember the common potential is C1 V1 plus C2 V2 by C1 plus C2. It is a direct application of this equation, and here V is same as V1 and C2 is uncharged, means V2 is 0. So, this goes off. So, your final answer is therefore C1V by C1 plus C2, and therefore, the C is the correct option for question number 17. Going further, 3 capacitors each of capacitance C and of breakdown voltage V are joined in series. Capacitance and breakdown voltage of the combination will be. So, notice that when you put capacitors in series, the charge is same, but potential difference divides among them. So, if both are equal, for example, if I apply some 100 volt here, if both are equal, both of them will get 50 volts. Now, the breakdown voltage means the insulator present inside, so whatever dielectric you have put, starts conducting beyond a particular voltage. That is called breakdown of the dielectric because of high electric field. That happens because of too much of polarization in the dielectric. Charges are removed from the atoms and it gets ionized and starts conducting. So, there is a safety voltage for each of the capacitor, that is the breakdown voltage. So, what is important? That breakdown voltage depends on the electric field present here, and the electric field present in the capacitor is V by D, where D is the distance between the plates and V is the potential difference. And now, D is same whether you put in series or parallel, but when you are putting in series, this V is reducing. So, therefore, if you are having 3 of them, if that is also having 50, then the total becomes 150. So, if one capacitor has a capacity to resist 50 volt, then putting them with 3, each of them get 50 only. So, end to end I can apply 150 volt, even then it is safe. If the limit is 50 for one capacitor, putting them in series, the limit becomes 3 times. So, if the breakdown voltage V is for one capacitor, putting 3 of them in series, breakdown voltage becomes 3V. Then, putting them in series will reduce, already I have told, capacitance in series is C by N, whenever you put N equal capacitors. So therefore, you are putting 3 equal capacitors, so it becomes C by 3. This is the capacitance of the equivalent combination, and this is the breakdown voltage of the combination. So this and this together are present here. So and therefore, option C is the correct one for the question number 18. Going further, two thin dielectric slabs of dielectric constants K1 and K2. So this is K1 and this is K2. K1 less than K2. So this information is given. So this K2 is a dielectric with a higher value of dielectric constant, or inserted between the plates of a parallel plate capacitor as shown. So they are kept parallel as shown. Plus and minus charges on the plates are also shown. Variation of electric field between the plate with distance d. So d is taken as a variable here instead of x, as measured from the plate P. So distance from the plate P is taken as d, is correctly shown by which of the graphs? So remember, electric field, if there is no dielectric with plus to minus, it is a constant in this direction. So if there is no dielectric, electric field graph should have been E with respect to distance should be a constant. Now, because you have a dielectric, the electric field inside the dielectric is E outside divided by K, and K is always a number more than 1, and therefore this should be less, and therefore wherever you have a dielectric, the value should be less. So it is constant here, it should be less here, and again constant here, it should be less here, again constant here, because you have 3 regions of air or vacuum, 2 regions of dielectric. So from the constant level, it should decrease here and here. First thing to remember, it should become like a step like that. Now the next thing, if K is more, E becomes still less, and therefore in the second place it should decrease more. The step should still come down like that. So therefore the correct option is C, which shows the variation of electric field. So these 3 constant region corresponds to the blanks, and these 2 correspond to the dielectric. The smaller decrease is for K1, larger decrease is for larger value of K2. So therefore final graph goes like this up to D. So this is the variation of electric field. Option C is the correct option for question number 19. Going further, a parallel plate air capacitor of capacitance C is connected to a cell of EMF V and then disconnected. So notice that it is disconnected before doing anything. So I have already explained, when the capacitor is disconnected from the cell, the charge on that cannot go anywhere. So you should use the concept Q is same before and after you do something. So that is the important thing to remember. Then a dielectric slab of dielectric constant K, which can just fill the air gap of the capacitor, is inserted. That means before there was no dielectric, you should take it as C naught. After you have a dielectric, you should take it as CD, or you can just take it as C and C dash. So because you have inserted a dielectric, this capacitance increases K times. So this and this together should give you all the other answers. So that is the way you have to practice doing questions of this kind. So let us do step by step. Because the capacitance increases, Q is same. So the basic equation is C is Q by V. We will use that for this one. And in this case, Q has not changed and C has increased. So if you substitute this C dash as Q by V dash, because Q is same, C is substituted as Q by V, which was earlier. So comparing these two, V dash is V by K. So potential decreases K times. This is the correct one. And you should not be in a hurry to tick this and go further without looking into others. Because if you analyze, you will see that this is also correct and remember you have to read the question carefully. It says which of the following is incorrect. So this is a negative question. You are recognizing the one which is wrong, and therefore whenever there is a negative question, to remember that you can just underline, otherwise you will be doing questions quickly and in a hurry. As soon as you get the correct one, you will tick that and go further without reading anything. So first answer we got is V dash is V by K. Then energy stored is half CV square. It was earlier, and later it is half C dash and V dash square. Therefore it is half C becomes Kc, C dash is Kc, V dash is V by K. So V dash square by K square, 1K gets cancelled, and therefore V square by K square, right. So V dash is V by K squared. So half CV square is divided by K, so and therefore energy decreases K times is also correct. And because it is decreased by K times, earlier value half CV square by K is the value after, half CV square is the value before, and if you take a difference that represents change in energy is also correct. So what is wrong? Charge is not conserved is wrong, because this is the main factor. Charge is conserved because charge cannot go to the cell or come out of that and all, because it is disconnected. So this is the option which is incorrect, and therefore you have to choose option D for that. Going further, in the given figure, capacitors C1, 3, 4, 5. So 1, 3, 4, 5 have capacitance 4 each. So each of this has 4, and the other one C2 has a capacitance 10. Now effective capacitance between A and B. So end to end you have to find what is the effective capacitance. So notice that if you take out these 2 points, this and this, imagine that you are stretching out like this and then writing it in this form, A here, B here, and I will call this as P and Q, A to P and B to Q. A to P you have a capacitor, A to Q also you have a capacitor, B to Q you have a capacitor, and B to P you have a capacitor, and all these are 4. P to Q you have 10. This is 10. So notice that by symmetry this is like a balanced bridge, and therefore P and Q will be at the same potential. This capacitor is ineffective, and because it is ineffective you can neglect that, this as though this is absent. You can do the circuit as though that is absent. So therefore what happens is you have to consider only these 4, and now it is very easy to do. These 2 are in series, 2 capacitors in series becomes half of C, so this becomes 2, 4 and 4 in series becomes 2, 2 and 2 in parallel becomes 2 plus 2, 4. So finally between A and B you are getting 4. The correct option for 21 is 4. Going further, 5 capacitors, each of value C, it is shown here, are connected as shown. Ratio of capacitance between P and R and also between P and Q. So you have to find the ratio. Always this order is important, don't mix up. C, P, Q, this is what you have to find. So do them separately, ratio of them. So first you find CF, PR. So between P and R, you have one branch here, another branch here. First you have to simplify whatever is there in the branches. So in this branch, 2 of them are in series, so that it becomes half of C. So if you consider P here, R here, in this branch it becomes C by 2, and here 3 are in series, and therefore it becomes 1/3 C by N. So this branch it is C by 3, and because these two are in parallel, you have to add them. So, C by 2 plus C by 3, 2 and 3 LCM is 6, you will get 3 here and 2 here. So, it is 5C by 6, first answer. Then going to the next one, you have C PQ to be found, and therefore, your point of consideration is P and Q, this and this. So, you have one branch here and the other branch here. Whatever is in a branch is in series. So, one branch is only C and this is the other one. So, these two are in parallel. So, one branch has C because the other is parallel, plus all this together 1, 2, 3, 4, like C by N becomes C by 4. So, this 4 is the LCM, 4 plus 1, 5C, and you have to find the ratio of these two. So, 5C by 6 divided by 5C by 4, this gets cancelled. So, you are getting 4 by 6 or 2 by 3, which is same as 2:3, and therefore, the correct option is D for question number 22. Going further, parallel plate capacitor is filled with two dielectrics as shown. Ratio of its capacitance with and without dielectric. So, here I will just mention what is the normal method, and I will show you that you can get it by shortcut. So, the normal method is, this should be taken as two capacitors in series. This has D by 2, this has D by 2, this has K1, this has K2, is equivalent to one single capacitor with a distance D and some K effective value. So, this should be taken as epsilon A by D by 2 with K1. This is epsilon A by D by 2 with K2. This should be taken as epsilon A by D with K dash. And if this is C1, this is C2 and this is C series, you should use 1 by CS, 1 by C1 plus 1 by C2. Epsilon A and D, everything will cancel out. You will get the relation between K dash in terms of K1, K2, you will get some answer. So, notice that doing all this is a little roundabout and it takes a long time. Now, you can use the elimination method here with the condition of a special case. That is one of the techniques of elimination method. You take a special case of the question, apply that to the answer. The special case is chosen so that guessing the answer is easy in that special case. That should agree with the answer here, whatever agrees with this. So, what is the special case? I will say K1, K2 are same as K. Then everything here is K, no difference. And because everything is same, the effective K is same as K. K dash should be same as K. So, if K1 equals K2, then your answer should become K. So, if I put K and K here, I will get 2K, which is not possible, should not happen. If I put K1 equals K2, this goes to infinity, not possible. If I put K1 equals K2 here, I will get 2K square by 2K, which gives K, which is what you want. And if you put K1 equals K2 here, you will get 2K by 2K square, which gives you 1 by K, which is again wrong. So, if K1 equals K2 equals K, your K dash should also be K. So, with the special case K1 equals K2 equals K, answer should become K. That happens only for this one. So, obviously, by elimination method, we will say these are not possible and this is the only possible answer. So, this way of solving you have to practice, as I have already told, and if you do all this simplification, again because it is a reciprocal sum and all, you will get 1 by K1, 1 by K2, and you have a D by 2 here, you will get a factor of 2. So, finally, you will get 2K1, K2 by K1 plus K2 after a long time. But if you do this within about 15 seconds, you will get this answer as 3 option. Okay, going further, resultant capacitance between A and B in the following figure. So, you have to find the resultant capacitance between A and B, and whenever you have a large combination like that, you should start solving from the other side. Okay. So, first take these 2 points, you have this and this 2 branches. In this branch 1, 2, 3 capacitors are in series. So, the effective value is C by 3 and this is 3. So, effective value becomes 3 by 3, which is 1. So, it is 2 parallel 1. So, all this becomes 1. 2 parallel 1 is 3. So, this whole thing becomes a 3 here. So, for the next step 3, 3, 3 in series again becomes 1 and this is equal to 1, all this 2 parallel 1 again becomes 3. Finally, 3, 3, 3 finally becomes here 1 and you will choose this as the answer. Now, again I will tell you what is the possible shortcut method. The shortcut method is, let us say all these things together becomes some x, whatever it is. So, your final answer should be some x here, 3 here, x here. 3 and 3 in series becomes 1.5. So, finally, it should be 1.5 and x. 1.5 and x in series, I have already told CS is always decreasing the effect. Your answer should be less than 1.5. So, just by looking at these 2 in series 1.5, whatever happens here, it should be less than 1.5. All these 3 are not possible. This should be the answer. So, this is an easy way of elimination method which will save you a lot of time. Looking at the trends here, you can decide. So, you are using this concept, CS should be less than the least in the combination. So, if you use that, immediately you will get the answer. Going further, see here actually this is the only easiest way of doing whatever I explained in the previous one. Otherwise, what should be done, I will just tell that if this comes as a board exam problem like that. So, you are using the concept, even if you remove one branch from here, remaining is also infinity. While removing, should you remove here or here, you have to do it carefully. So, after you remove, what remains should appear like this. So, obviously, you have to remove it here. This, if you take A and B, and this remaining part up to infinity is exactly same. One removed from infinity is still infinity, so it does not matter. So, therefore, if your answer CAB is x, this also should be x. So, this should be taken as C2 here, C1 here and C2 again here, and all that remaining is x. So, you will say your answer CAB should be equal to this combination. So, C1 plus x, C2 and C2 in series. So, 1 by C2 plus 1 by C2 plus 1 by C1 plus x should be equal to 1 by answer, which is also x. So, solving this, you should get the answer because C1, C2 values are given. So, obviously, this is a little roundabout method. So, what is the shortcut method here? Again, use the same logic. This is 1 and this is 2. Now, take all this as some one single value, whatever happens. It is in series with 1 and 1. 1 and 1 series is already 0.5. 0.5 in series with anything should be less than 0.5. So, answer should be less than 0.5 and this is the only one like that. So, and therefore, all these are not possible. Without doing much of calculation, you will say B is the correct option for question number 25. Then, there are many variations of this question. 4 metallic plates are given as shown. Alternate plates are connected to A and B as shown. What is the effective capacitance? So, in all questions of this kind, every pair of plate which is separate should be taken as one capacitor. So, you have one capacitor, another capacitor, another capacitor. I am not writing C1, C2, etc. because all are identical. the distances are equal and all. So, each of this area A, distance d. So, each capacitor is epsilon naught A by d. So, you have 3 capacitors. If you call the plates as 1, 2, 3 and 4, between 1 and 2 you have a capacitor, 2 and 3 you have a capacitor, 3 and 4 you have a capacitor. Now, observe how they are connected. This first capacitor is between A, one end goes to A, other end goes to B. So, if you consider A, B, 1 and 2 or like that. Then if you take the next one, 2 and 3, another capacitor here between these two, 2 goes to B and 3 goes to A. So, I have another capacitor here, 2 goes to B, 3 goes to A. Then you have another 3 to 4, 3 goes to A and 4 goes to B. So, 3 goes to A, 4 goes to B. So, notice that only difference is this and this is common, it does not make any difference here, this is common. So, this is equivalent to 3 capacitors in parallel and therefore, it should become 3C, each C is this. So, 3 into this should be your answer. So, therefore, for question number 26, the option is C, correct option. So, in all questions of this kind, identify how many capacitors are there, identify the end plates of that and then find out how they are connected, convert like this, then you decide series, parallel and all and get the final answer. So, this is just given as an example. Going further, a copper sphere of mass 2 gram contains about 2 into 10 power 22 atoms. Charge on the nucleus is 29 E for copper. Mass of electron is given. How much mass in this sphere, lose or gain, if it is given a charge of plus 2. So, actually this is not a question on capacitors. So, it is on the fields and charges. So, here it is very easy to do that. Because you are giving a plus charge, it is possible because it is a metal, plus charge cannot be given by adding positive charge, plus charge is given by removing electrons. And because you are removing electron, some mass is lost. So, mass is lost should be the answer. Now, you see this should be the answer because others are wrong. And therefore, by elimination you can decide this as the answer, but still for learning purpose you can calculate how much mass it loses, that is this value depends on how many electrons are removed and into mass of each electron. So, number of electrons removed is 2 microcoulomb divided by charge of the electron into mass of each electron. This answer will be in kg. To convert it to gram, you have to multiply it by 3. So, if you simplify, you will get back the same answer. So, that you are choosing A as the option for the question 27. So, this is also a question based on the equilibrium of charges. So, here anyway the diagram itself is self-explanatory. You have 2 charges in equilibrium in this fashion like 2 pendulums. So, here they are repelling. So, there is a force here and also here. Both of them have weight. So, there is a weight here and you have some tension in the string, and because they are in equilibrium it is enough to consider any one of them. So, when you do like this, the components of this T, if you resolve, this is theta, this becomes adjacent component. So, it is cos theta and this is the opposite component opposite to theta. So, it should be sin theta. This is balancing weight, this is balancing F. So, T sin theta is balancing force between them is 1 over 4 pi epsilon naught product of the charges divided by distance square, and T cos theta is balancing mg. And if you divide, T gets cancelled, you are left with tan theta is equal to 1 over 4 pi epsilon naught q square by x square, and mg is also present here. Now, they have given theta is small, so that tan theta can be taken as sin theta. and sin theta can be taken from this triangle. So, in this triangle this is L and this is x, x by L is sin theta. So, this should be tan theta should be equal to sin theta, which is x by L. So, taking this x here, you will get x cube. So, that this x comes here, it becomes x cube, this L comes here. So, your answer should be cube root of this part, q square L 4 pi epsilon naught mg, and therefore, wait a minute. So, I have left out a by 2 here. So, you have to be careful. While doing sin theta, this should be taken as x by 2 because total is x, and therefore, you have a 2 here, and that 2 will cancel with this, giving a 2 here. So, 2 pi epsilon naught mg should be in the denominator, q square L in the numerator, cube root. That should be the option A. So, you have to be careful because this kind of mistakes can happen if you are in a hurry and also if you are under tension. So, you should be careful because whatever mistake is possible, they are called expected wrong answers, and that is already present here. So, if you do some mistakes and get something which is already present here, does not always mean you are correct. So, therefore, you have to do the numericals very carefully. And going to the next one, infinite number of charges placed q at 1, 2, 4, 8 like that. So, I have an axis 0, 1, 2, 4. So, at each point you are putting a charge like that. You have to find the potential and field in SI unit at this origin. So, for the potential, it is 1 over 4 pi epsilon naught, charge by distance, all of them to be added. So, because q is common, I will take it out. For the first charge, distance is 1. For the second charge, distance is 2. For the next one, it is 4. So, you see that this is a geometric progression, 1 plus half etc. finally becomes 2. So, therefore, this is 2q into 1 over 4 pi epsilon naught, that is present here. So, already you know that these two are wrong. And if you consider the field, it is similar, 1 over 4 pi epsilon naught charge by distance square. So, 1 by 1 square, 1 by 2 square, 1 by 4 square, like that it goes on. This is a GP with a common multiplication of 1 by 4, and therefore, the sum to infinity of the GP is 1 by a minus r, becomes 1 by 1 minus 1 by 4, that becomes 4 minus 1, 3. So, finally, it becomes 4 by 3. So, you will have a 4 by 3 times q, and therefore, this is not possible, this should be taken. So, for the question number 29, the correct option is D. Then going further to question number 30, electric potential at any point, all in meters xyz, is given by this. Electric field at 1, 0, 2. So, this is x, y, z coordinates of a point. So, notice that a potential is varying only in the x direction, and therefore, electric field should be only in the x direction, y and z direction it should be constant. And electric field is the negative potential gradient, minus dV by dx will be minus 8x. So, minus of x means it is in the negative x direction, and 8 is the value if x is 1 for this point. So, therefore, it is 8 along the negative x direction. For the question number 30, this should be the answer. In a hurry, you should not take A. So, now notice that you can do a little faster in the other way. Once you get 8x, as x increases, potential increases. So, potential is increasing this way, it is decreasing this way. And I have already told the concept, if you go in the direction of electric field, potential should decrease. So, this should be the direction of electric field. That also makes you understand that it is negative x axis. Then coming to the next one, a charge of 5 nanocoulomb having this much of mass is approaching another fixed charge, notice that is not moving, with a velocity, distance of closest approach. So, if I have one plus charge and another moving, because of repulsion this becomes gradually slow, stops here and goes off like that, and it cannot come closer than this. So, at this point it has stopped, and therefore, it has only potential energy because of the two charges. And at a long distance, when the potential is negligible, it had only kinetic energy. So this is very similar to a stone which is thrown up, it goes and comes back, it stops here, kinetic energy here is equal to potential energy here, same concept is used. So kinetic energy is half mv square, half mass is 50 milligram is 10 power minus 6 kg, v square is 0.5 square is 0.25. This should be equal to potential energy 1 by 4 pi epsilon naught product of charges by distance which you want. So 1 by 4 pi epsilon naught is 9 into 10 power 9, product of charges 5 nano coulomb into 10 nano coulomb divided by distance. So you have to solve for x. So this 5 into 10 50 gets cancelled, okay, and you are having 9 here, and 0.25 with 2 cancels with 8, and therefore when you take x and this here, it becomes x equals this 10 power 6 comes here with 10 power plus 6, okay. So therefore these two are cancelling, you are left with only 10 power minus 3, 72 10 power minus 3. So that is therefore 0.072. And now you can also use little bit of elimination here. Once you know that you are getting 72, don't worry about all the powers and all, because answer should have 7 and 2. So all these are not possible, only this should be the answer. Even if you don't simplify 10 powers exactly, you can decide that this is the answer. So for question 31, the correct option is D. So we have discussed all the questions on potential and capacitance. Practice based on the hints and shortcut methods that I have told. So I hope you can do well in the exam with all this practice. Thank you.